Scientists believe that there is an extremely massive black hole at the center of the Milky Way. How many times more massive than the Sun would a black hole with a mass of 7.36 times 10 to the 36 kilograms be? The mass of the Sun is approximately 1.99 times 10 to the 30th kilograms. So to find out how many times more massive the Sun would be, we take this new black hole, which is 7.36 times 10 to the 36th, and divide to figure out how many more times it is. So divide by 1.99 times 10 to the 30th. These are both kilograms. We can divide our number parts here. Just take 7.33 divided by 1.99, and when we do that, 0.36 divided by 1.99, we get 3.7-ish times 10. Here we're dividing powers with the same base. And when we divide powers with the same base, we subtract our exponents. So 36 minus 30. It's going to give me 3.7 times 10 to the 6th. So it's 3.7 times 10 to the 6th times more massive. Again, dividing powers with the same base, which is what we have right here, means we subtract our exponents. Our number parts we can just divide by like normal. There's no exponents we have to worry about. We just take 7.36 divided by 1.99 and get 3.698, which I rounded to 3.7. Number 45, we have a quotient to a power. And just like when we have a product to a power, we take our exponent to both pieces. We're going to have b squared over 7 squared. And we want the simplified form, so I'm going to take that 7 squared and go ahead and simplify that to 49. We're going to have b squared over 49. Same idea here. In 46, take a second to figure out how many things are being multiplied or divided. Right now we have 1, 2, 3, which means I need to take my exponent to all 3 pieces. So I'm going to have 3 cubed, and that started in the numerator, so it stays in the numerator. The 5 started in the denominator, so it stays in the denominator. And y to the 9th to the 3rd power started in the denominator, so it'll stay in the denominator. 3 cubed is 27. 5 cubed is 125. And we have a power to a power, which means we're going to multiply our exponents. 125 times y to the 27th in the denominator. So 27 over 125 y to the 27th. 47, same idea here. Again, we have 1, 2, 3, 4 factors, which means I'm going to take that exponent to all 4 pieces. I have 4 to the 3rd in my numerator, k to the 4th power to the 3rd power in my numerator. In my denominator, I have 7 to the 3rd power and c to the 3rd power to the 3rd power. Again, they stay wherever they're at. 4 cubed is 64. Power to a power means we multiply our exponents. 4 times 3 is 12. 7 cubed is 343. Multiply our exponents here, c to the 9th power. So I get 64k to the 12th divided by 343 c to the 9th. And if we could, we'd simplify the 64 and the 343, but we know that they're just 4s and 7s and nothing simplifies there. (48). Again, 2 ways we can do this one. So the first way is we can take that -3 to all the pieces. we'd have m to the negative first power, to the negative third power, m to the fifth power, to the negative third power, and m to the negative second power, to the negative third power. Then we could simplify that. Power to a power means we multiply our exponents. Positive 3, negative 15, positive 6. Multiplying powers with the same base means we add our exponents. See, negative 12. Now we're dividing powers with the same base, so we take m to the negative 12 minus 6. M to the negative 18th power. We don't leave a negative exponent, so we move it to the denominator and make it positive. And we get 1 over m to the positive 18th power. The other way we could do this problem is we could get rid of the negative exponent right away. And we do that by taking the reciprocal of whatever's inside. Whatever's in the top goes to the bottom, and whatever's in the bottom goes to the top. So we'd have m to the negative 2 over m to the negative 1, m to the fifth. And again, we don't change anything inside of there. We just change its position and make it a positive 3. Now we take our exponent to each piece. We get m to the negative 6 over m to the negative 3, m to the positive 15. Now where our multiplying is in our denominator, so we would add our exponents. Negative 3 plus 15 would give me a positive 12. Dividing powers, same base here. So what I do is I subtract my exponents. Negative 6 minus 12 gives me m to the negative 18th power, which again, I move to the denominator, make positive, and put a 1 in my numerator. So I'd still have the same 1 over m to the 18th power. So it does not matter which one you do first, whether you distribute your exponent or you make it positive first. Does not matter. Same thing here in 49. So in 49, I can make my exponent positive first if I want to. And to do that, I reorder my fraction. Top goes to bottom, bottom goes to top. That's how I change my exponent. So 4c to the fifth over m cubed to the positive 4 power. Now I take that fourth power to all of my pieces. 4 to the fourth, c to the fifth power to the fourth over m cubed to the fourth power. 4 to the fourth power is 256. Power to a power means I multiply those. 5 times 4 is 20. And power to a power means I'm going to multiply those. M raised to the 12th power. Again, if we wanted to instead, we could have distributed that power first. M to the third to the negative 4th power over 4 to the negative 4th power, c to the 5th power to the negative 4th. We had m to the negative 12th over 4 to the negative 4th, c to the negative 20th. Okay, we had to move to get our exponents positive to the opposite part of our fractions. So it had 4 to the 4th power, c to the positive 20th power, m to the positive 12th power, which still would have given me 256, c to the 20th power over m to the 12th power. And remember, I can't put that c to the 20th and the m to the 12th. I can't do anything with those exponents because they have to have the same base, and there I do not. 50. Same idea here. I'm going to go ahead and make it positive to start with because the less number of negative exponents we have to deal with, usually the easier things go. We don't have to remember to keep them negative, and we don't have to remember to move them. So in order to make this positive, we take the reciprocal of our fraction. We flip it. Top goes to bottom, bottom goes to top. Which means I'm going to have 8j to the 4th power over 3x to the 5th to the positive third. Now, I take that exponent to all my pieces. I have 1, 2, 3, 4 things that are either being multiplied or divided. So I take that 3 as an exponent to each piece. 8 cubed, j to the 4th power cubed over 3 cubed, x to the 5th power cubed. 8 cubed is 512. Power to a power means I multiply my exponents. 3 cubed is 27. Power to a power means I multiply my exponents, x to the 15th. So I'm going to have 512 j to the 12th divided by 27 x to the 15th power. Last one. Astronomers measure large distances in light years. 1 light year is the distance that light can travel in 1 year, or approximately 5.88 times 10 to the 12th miles. Suppose a star is 1.92 times 10 to the 3rd light years from Earth. In scientific notation, approximately how many miles is it? Okay, so we're going to start off with light years here, because that's what we know about the star. We know the star is 1.92 times 10 to the 3rd light years. We're looking for how many miles. So I'm going to take 1.92 times 10 to the 3rd light years. I don't know how you abbreviate light years, so I'm going to go like that. And we're going to use a conversion factor. I'm going to multiply by, right now I have 1 light year is this many miles. So because I'm trying to get to miles, and I'm trying to convert from light years, I put miles on top because I want my light years to cancel, and I'm looking for miles, so miles has to be in my numerator. I'm going to plug in my values here. It's 5.88 times 10 to the 12th miles in 1 light year. So I'm going to multiply across 1.92 times 10 to the 3rd times 5.88 times 10 to the 12th. We take our number parts and multiply those together. So I take 1.92 times 5.88, and I get 11.2896, so 29, times 10. I'm multiplying powers with the same base here, which means I add my exponents, 3 plus 12. Gives me 11.29 times 10 to the 15th. But my answer is not in scientific notation. I have to move 1 spot to get in scientific notation, which means I add 1 to my exponent. When I go from a big number to a small number, I have to add 1 to my exponent to get back to where we started, which means I have 1.13 is where the quiz rounded to, 2 decimal places, same here, times 10 to the 16th, and we're looking for miles. So make sure when you come to class tomorrow, you have written down which problems you still have questions on, and we'll go through those in review before the test on Friday.